Hey everybody. So we have dealt with part of our statistics where we talked about box and whisker plots, frequency distributions, um, pretty much like histograms, dot plots. We also have talked about all the other stuff that we've done. We've talked about so much about like surveys and types of samples and all that great stuff. So with that, probability goes into statistics also and uses the same type of stuff. So just like we did kind of like with a frequency distribution, we're gonna be dealing with a probability distribution. So that's what we're gonna talk about on this video. All right, so in class, right after this video, or right after this title, I would go to an activity with you guys. In class, you'll do that, and we'll come right back after that. All right, so that table that we just made, that is actually a probability distribution. So they're actually used to make real life decisions. And this is what people really use, whether it's like going to a casino trying to figure out should we go ahead and gamble with this game, or should we go here and look at our life insurance? Should we gamble on this life insurance versus this life insurance? Like which one should we go with? Probability distributions are used everywhere to try to make real life decisions. So a formal definition of a probability distribution is a table of all possible outcomes in a sample space and their probabilities. So all the possible outcomes that can happen in that sample space and the probabilities. But then you might be like, okay, well, what is the sample space? Glad you asked. Sample space is just all the possible outcomes. So a probability distribution puts the possible outcomes along with the probability of it happening. So the chance of it happening, so the outcomes and the chance of it happening. So that's what that is. So let's go to a quick like example type thing. So for example, let's roll a single die. We know on one die, we have 6 sides on it. So we have 1, 2, 3, 4, 5, 6. So our sample space is 1, 2, 3, 4, 5, 6, because there's 6 outcomes here. Remember, sample spaces are all your possible outcomes. So here are sample spaces 1, 2, 3, 4, 5, 6 on a regular die, a 6-sided die. Regular die. All right. Now, with that, the probability of getting each event, so in other words, the probability of getting a 1 is 1 out of 6. Probability of getting a 2 is 1 out of 6. Getting a 3, 4, 5, or 6, excuse me, getting a 3, 4, 5, or 6, the probability of getting any of them is just 1 out of 6. Because there's one choice out of the 6 possible choices. 1 out of 6. All right, so our probability is 1/6. Our sample space is 1, 2, 3, 4, 5, 6. All our possible outcomes. So our probability distribution would look like this. So on top, you can see all the possible outcomes. So we use X there as the top one to talk about the outcomes. So we know we can have a 1, a 2, a 3, a 4, a 5, or a 6. The second line is your probabilities. So P of X is talking about probability of X happening. So what's the probability of getting a 1? Is 1 out of 6. What's the probability of getting a 2? 1 out of 6. Probability of getting a 6? 1 out of 6. That's a probability distribution. That's it, guys. That's really what it is. So it's just making a table to display the outcomes and the probability that it can happen. So guys, it's really not that bad. All right, now there are different types of probability distributions. And these are our types right here. Oop, don't want to show you all that. All right, so we have a discrete probability distribution and a continuous probability distribution. Got them both. So let's talk about each individual one so we can know what we're talking about. But for really so that you know now, the one that we're going to talk about right now is actually the discrete one. That's what we're going to spend our most time on this lesson, and go in the future a little bit more. All right. So discrete probability distribution is a probability distribution where we can count the outcomes. So you can count how many outcomes there are. So if you can count them, it's a discrete. So, for example, like that die example we just did, the single die, um, a die example is discrete because you only have 6 outcomes. You can count that 1, 2, 3, 4, 5, 6. You can count that how many outcomes there is. But when it comes to something else, like yeah, and we go to the next part. I'll explain that. But again, if you can count the number of outcomes, it's a discrete probability outcome, right? Probability distribution. All right, now the other one is a continuous one. So continuous is a probability distribution where there are no gaps in the sample space. You might be like, okay, what does that mean? So, for example, here, if you're thinking about the die one, remember there's a 1, 2, 3, 4, 5, or 6. So you can either have a 1, a 2, 3, 4, 5, or 6. That's it. You cannot have a 1.5 or a 2.2 type thing. You can't have any of those. So it's the first one is discrete, not concrete, but discrete. It's one of these numbers. When it comes to continuous, it means it can go on forever. So like between 1 and 2, if we were looking at a continuous thing, that wasn't dealing with the die, there's multiple numbers between 1 and 2. Like you can have 1.1, 1.01, 1.0000000000001. So this is like multiple numbers. It's continuous. It goes on forever. Like you can't stop it. So with that, hopefully that makes sense. If it didn't, it's okay. Because we're not going to spend a whole lot of time on this one. We're going to come back to it later on in other lessons. But here are some examples of things that would be a continuous probability distribution. Like if you're trying to figure out the weight, there's so many different weights. Like you can actually weigh something, whether it's tons, whether it's pounds, whatever. It's continuous. It goes on forever and ever and ever, and you can't really find an end to it. Same thing for time. Same thing for height. Pretty much things that can go on forever and ever and ever. Yeah, there's no fixed end point for that. It's continuous. It goes on forever. All right, so we have that. We're good on that. So we have the types of probability distributions. Now, in all of this, there are two different characteristics that, again, like I said, we're going to go back and we're going to focus on discrete probability right now. That's what this lesson is going to focus on that. So we're going to talk about there's two different characteristics that must happen in order for a probability distribution to be discrete. All right, these are our two things right here. Bam, in your face. All right, so two characteristics. One, the probability of each event must be between 0 and 1. So the probability of something happening cannot be more than 1. It has to be between 0 and 1. But if you look at all the possibilities that can happen, when you add them all up, it should equal 1. So all of our probabilities, all of our percents should be equal to 1. And you're like, yeah, Mr. Hall, I don't really get that. Like, that just doesn't make sense. Okay, so we're going to talk about that. We're going to see that. So again, one more time, the two characteristics. One's probability of each event must be between 0 and 1. And the sum of probabilities is 1. So let's get an example type thing here. It's not for an example. It's like for example, not actually example 1. Let's look at this. We're going to take a look at the questions later on. We're not going to answer that yet. But I'm going to talk about the characteristics that must happen. So we said first off that each probability for the event must be between 0 and 1. So every event, so every one. So this one, this one, this one, this one, this one, and this one. 1/6 is between 0 and 1. So every single one of these probabilities is between 0 and 1. Yeah, right? It's between 0 and 1. Probabilities. Okay, cool. That checks off number 1 for the two characteristics. So number 1, bam. Then we said, again, the second characteristic, and guys, this is very important, very vital. It must happen. The first one must happen too, like we just did right there. But the second one must happen. If you add all of these up, all these probabilities, they must equal 1. If it does not equal 1, it is not a discrete probability distribution. It's not. So you must have it equal to 1. So if you do that, if that happens, so if these two things happen, this is less than 1, each individual one are less than between 0 and 1. And when you add them all up, it equals 1. You have a discrete probability distribution. Woo! Yes, sir. Yes, ma'am. All right, so coming back again to that table we had about the die, rolling the die and everything. We said, okay, there's 6 outcomes, 1, 2, 3, 4, 5, 6. We said there's probabilities of 1/6 for each one of them. And now let's answer these 3 questions from that. So question 1, what is the probability of rolling an even number? Okay, so let's take a look at that. So we're going to do that part. We know 2 is an even number, 4 is an even number, 6 is an even number. So for 2, there's a 1/6. For a 4, there's a 1/6. And for 6, the probability is 1/6. So all those equal 1/6. So to find the probability of an even, we're going to do 3/6. Not bad. That's easy. Later on, we'll talk about more in depth if we need to. We can actually talk about the ands and ors and all that great stuff. All right, the next thing is, what is the probability of rolling a number that is greater than 3? It's a number that's greater than 3. So if it's greater than 3, it does not equal 3, right? It's just numbers that are bigger than 3. So numbers that are bigger than 3 is 4, 5, and 6. Right, so for 4, the probability is 1/6. For 5, probability is 1/6. And for 6, the probability is 1/6. Just add those 3 together, sorry. And again, that gives us 3/6. Now with that, keep that. Don't change it to like a decimal. Don't change it to a percent yet. We can do that later on, but keep it as a fraction there. All right, and then the last one, let's go to that real quick. It says, what's the probability of rolling anything but a 6? So you can look at that real quick. Y'all should be able to look at it and be like, oh yeah, we know what that answer is. That's 1, 2, 3, 4, 5. So that's 5 1/6s. Or you can tell me the answer already as 5/6. All right, so again, there's 5 of them. The probabilities are 1/6 each. So we add them up and we get 5/6. So guys, this is not bad. It's not bad. You're gonna have stuff like this on the homework, on the activity sheet and stuff. So homework part. So just make sure you're ready for that. But that's easy, right? Easy stuff. All right, so we're almost done, guys. We're almost done.